Hello class. So as promised, I'm gonna I'm gonna teach you how to solve this type of problems, application problems. And let's start. I'm gonna solve two, at least two. And if I see that there's more time available, I can solve perhaps a third one. So let's start. The first thing I want to tell you guys in regards to this type of problems is the following, and it's very important that you understand this. There is no recipe. There is no recipe, guys, for solving this type of problems. Application problems, uh, otherwise known uh, badly as reason problems or word problems. Okay, I like to call them application problems, and there is no recipe. I cannot give you a list of things that you have to do, like do this first, and then do this, and then do that, and eventually you will get to the answer. No, I cannot give you that, guys, because the very concept of a problem itself, in general, is a statement. A problem is a statement, like this one or any other type, for which you require a solution, but in principle, you don't know what to do in order to get that solution. That's why it's called a problem. Okay? If we already knew how to solve it, then it would not be called a problem. It would be called an exercise. That is the difference between an exercise and a problem. An exercise is something that you already know how to do, and you just practice and practice and practice in order to have like muscle memory and mental memory. But a problem, in principle, you don't know how to attack it. So there is no recipe. Sometimes you have to read several times the problem in order to understand it. You have to try it. Uh, you have to just give it a shot. Okay, you have to try and try and try. You have to try different methods, different ideas. You have to be resilient. Okay, if a certain problem doesn't give up, okay, just try and try until you finally solve it. So let's do this one. I'm gonna think out loud as I always do, and try to pay attention to the way I think and try to emulate the way I think in a way. So let's start. Let's read the problem. This one goes like this. Dennis and Chris read, this is the last name, Dennis and Chris leave simultaneously from the same point, hiking in opposite directions. Okay, I'm gonna stop right there for the moment. And I'm gonna try to draw what is taking place. So I'm gonna draw this horizontal line representing my um, kind of like the surface or the road, okay, more or less. And I'm gonna say that this is the scale in this line are gonna be miles. Okay, 0 miles. This is my origin. 0 miles, 1 mile, 2, 3, 4, 5, 6, etc. And the same backwards. Okay. And if you remember, when we go backwards from the origin, these are negative miles. In this case, just like negative numbers. There is nothing wrong with something with a negative mile. All that it means is that it's at to the left of the origin. That's all it means. Okay, no mystery. Okay, so this is where my two people are gonna be walking. So let me put those two people right there at the origin. Here they are, both people, Dennis and Chris, and they're gonna walk in different directions. So since they don't tell me which one goes in which direction, I am completely free to decide on my own uh, for such choice. So I'm gonna decide for Dennis to move to the left and for Chris to move to the right. Okay, and that's it. With this little diagram here, I am establishing the first statement that they tell me. You don't need to draw the people, you don't need to draw any trees or whatever, okay? Try to keep things as simple as possible. Okay, let's continue. Now they tell me Dennis walking at 4 miles per hour and Chris at 2 miles per hour. So this is a piece of data that I have. And I can here I can have a section for all the facts or data that I know about the problem, okay? And what I know is basically the speeds of these two people, Dennis and Chris, their walking speeds. So basically I can do the following. I can write the speed of Dennis. Okay, I'm going to represent the speed of Dennis by this variable, and I know it to be equal to 4 miles per hour, and the speed of Chris is equal to 2 miles per hour. Okay, and maybe I can add information about what I mean as SD and SC, where SD is equal to the speed of, of Dennis and SC is the speed of Chris. You may think that this is irrelevant information or too much, but it's always a good idea to define your variables and to be very specific, okay? In this case, by doing this, the reader of your work will know exactly what you mean by SD and by SC. Because if you don't write this part, imagine that this is not here, and if somebody comes along and reads your problem, that person may not understand what you mean by this, may not, okay? So if you can clarify things like this, that's 100 times better. Okay, so let's continue. We were right here. Now, question, how long can they talk on their walkie-talkies if the walkie-talkies have a 30-mile radius? Okay, so let me draw a division line here. Let me continue my problem in this space. Always try to work from top to bottom and from left to right. When you run out of space, like I just did, now draw a something like this, a line, and start working here. When you run out of space, draw a line, start working here. I found in my experience that this is the one of the best ways to work. Okay, always have order when you write something. You cannot do things all over the place because as a teacher, I can tell you this. There are many students that like to work, if this is their notebook, and if they are solving a problem, they go like this. They do something here, and then they do something here, and then they do here something, and then that's awful, guys. This is not a proper way to work. Okay. Instead, if you go like this, if you say, okay, this is my problem, and I'm gonna start my solution right here, solution 2 points, I mean colon, sorry, and then step, I run out of space, division line, step, division line, step, solution. Awesome. You see, this is a perfect way to work. It doesn't have to be like this, but something similar, okay? Something that is intelligible, something that is readable for your reader, okay? It's very important you start to work in this way, in a very orderly way. It's one of the most essential skills in school. Okay, after that little comment, let's continue with the problem. So, as I was saying, what is the question? The question is, these people are going to walk in their respective directions and they have walkie-talkies in order to talk to one another. And at some point, those walkie-talkies will start failing because the distance between these two people will be enough for the walkie-talkies to stop communicating with one another. Okay, so what is that distance? 30 miles. 30 miles. After they have walked in such a way, such that, let's suppose that Dennis is already, I don't know, over here, and Chris is, let's suppose, here, someplace. At the point in which all of this distance, oops, they started here, okay. At the point in which this whole distance, all of this distance, is equal to 30 miles, then at that point, the walkie-talkies will start to fail communicating. Okay, so let's see. What can I find out? Well, Dennis, if this happens, therefore Dennis would have walked all of this segment, and Chris would have walked all of this blue segment. You see, this is the distance walked by Dennis and the distance walked by Chris, and the sum of both distances will have to be equal to 30 miles. So let's use that fact. Okay, first of all, I'm going to introduce one of the basic formulas of physics, which is the following. When a particle is traveling at a constant speed or constant velocity, we have that the distance traveled is equal to the speed times the time. Okay, the distance traveled by a particle is equal to the speed times the time that the particle travels. So this is one of the basic formulas in physics, and I'm gonna use it in order to solve this problem. I'm gonna write the following. Look, the distance that Dennis walks is equal to the speed of Dennis times the time that he walks. And the same for Chris. The distance that Chris walks, or the distance that Chris travels, is equal to the speed of Chris times the time t that he spends walking. You see? So basically, I'm writing this equation for each of my two people. And that's why these two things, guys, these subindexes, come in handy, because these subindexes tell you what distance of what person you're talking about. This is the distance that Dennis travels, and this is the distance that Chris travels. Because if I just write this equation, for example, in my analysis, one person can ask me, uh, what does this d mean? The distance walked by what person? You see, and that would be a very valid question. And I'm gonna be much clearer if I do this sort of thing with the subindexes. That's why people invented these subindexes. Mathematicians invented those in order to have more clarity. Okay, now let's go back to the diagram. If you remember, at the point in which we have 30 miles in between those two people, then what basically what we're saying is that the distance walked by Dennis, which is this yellow segment, and the distance walked by Chris, which is the blue segment, both of them, the addition will be equal to 30. So I'm going to write that as an equation. I'm going to write the distance walked by Dennis plus the distance walked by Chris will have to be equal to 30 miles. And I'm going to keep my numbers without units for simplicity. So I have these three equations, 1, 2, 3. I can erase this one because I have already written these two. We have these three equations, perfect. And now what I can do, guys, is combine these three equations. Okay, combine them. How? In this way. If you notice, the distance walked by Dennis is equal to this, so I can write the following. I can transform this equation into this one. This is equal to this, according to this, right? And then plus dc, which is this, equals 30. So I have this, by combining all of these equations, okay, I can create this other new equation, so to speak. And now I realize that I have these two numbers, SD and SC. They are 4 and 2 respectively. So I'm gonna put them in here. I'm gonna substitute, and I'm gonna make a division line here, and let me substitute in this equation. SD is 4 and time plus SC, which is 2 times the time, equals 30. And that's it, guys. Okay, once we get to an equation like so, we can notice very quickly that all we have to do now is solve this equation for t. Let's solve it. It's very simple. This is going to be equal to 60 equals 30, and therefore t equals 30 over 6, which is 5. 5 what? 5 hours, because we're talking about hours, right? So this is my solution. The problem is done. Okay, basically what this solution is telling me, the interpretation is this: these two people are going to start here. They want to Dennis is going to walk to the left, Chris to the right, and after 5 hours, after exactly 5 hours, the distance between them will be 30 miles, and therefore their walkie-talkies will start failing in communicating, which is what I wanted to know. How long can they talk on their walkie-talkies? If the walkie-talkies have a 30-mile radius, their solution is 5 hours. They can walk for 5 hours until their walkie-talkies go dead, so to speak. Okay, so that's the solution. So remember, try to work. You can see that all my process, my thinking process, is pretty much ordered, okay, and clear. And try to do the same. I know it costs more energy and more time, but it's much better. Okay, it's much more satisfactorily. Okay, now the other problem that I wanted to solve for you is this other one. I don't know why it's taking too long. These ones are not don't have to be done yet because we have not seen that topic. Yeah, this one. I wanted to do this one. Okay, let's see. Same idea, guys. Let's start to read. Let's try to work very carefully, and let's see how it goes. We have the following. Luis Nunez begins walking at a rate of 4 miles per hour. So same thing. I'm gonna place my road or my highway or whatever, and I'm gonna say, okay, this is my origin, and I'm gonna say that Luis starts walking from this point. In what direction, it doesn't matter, but let's use the right direction. So Luis is coming in this direction. 1 mile, 2 miles, 3, 4, 5, etc. Minus 1 mile, minus 2 miles, minus 3 miles, etc. Fine. And then they tell us 30 minutes after he leaves, his wife Kristen realizes that Luis has forgotten his wallet. Kristen gets on her bicycle and begins riding at a rate of 24 miles per hour along the same path that Luis took. And then they ask us two questions. How long will it take for Kristen to catch Luis? And how far from their house will Kristen catch Luis? Oh, so Luis was in their house, okay, when he started walking. Okay, so let's solve this problem. Same idea. In here, somewhere we can have our facts or data, space, and what do we know? We know the each of the speeds of both people, right? Luis's speed is 4 miles per hour, which I'm gonna write like this. The speed of Luis is 4 miles per hour, and the speed of Kristen is 24 miles per hour. And I do the same, where SL is the speed of Luis and SK is the speed of Kristen. Okay, fine. Let's continue. Okay, what else do we know? Okay, we know that this is the important difference with respect to the other problem. The difference, guys, here is that even though Luis and Kristen, both of them, I'm gonna represent, both of them will travel in the same direction, but not at the same time. First, Luis takes off, and he's gonna walk in this direction, and then after 30 minutes, Christine is gonna walk in the same direction in order to catch Luis. Okay, so basically we have to have a difference in the equations. You're gonna see the difference in a moment. Remember, the distance covered by a particle is equal to its speed times its time traveled. Okay, so I'm gonna write two equations, one for Luis, one for Christian. The distance traveled by Luis is equal to Luis's speed times the time that he has walked, and the distance, well, I'm gonna write it here also. The distance covered by Christian will be equal to the speed of Christian times the time that Christian has been riding. But there's a difference between this t and this t, and this is a little hard to understand. Okay, there's gonna be a difference in here. What is the difference? The difference is this, guys, that they are um, they don't start to walk or to travel at the same time. Okay, they don't start to travel at the same time. First Luis takes off, and after 30 minutes or half hour, then Christine takes off. So the time that Christine has been traveling with respect to the time of Luis is actually the following. Look, t minus 0.5. Let me tell you why. Because it's tricky. These things are a little tricky. I need to make this distinction. Okay, why? Because t, let's say what let's first agree on what t means. T is the time that has passed since Luis started walking. Okay, you can imagine that at the time Luis decides, like, okay, I'm gonna go walking, then you can think that he has a chronometer, okay, on hand, or a clock or whatever, and at the moment he starts walking, he's gonna he's gonna start the clock. Okay, so the time is already going, you see, and basically Christine is gonna start walking 0.5 hours after Luis. You see what I mean? So it's not the same. It's not the same time. It's not this time and this and the time for Christine in these two equations cannot be the same. Why am I introducing this little minus 0.5 in here? Minus 0.5 hours. Why? Because of the following. Let me erase this. Because of this. Look, if I don't put it, if I don't write it down, if I just keep it like so, then I'm gonna run into a contradiction. What contradiction? The following contradiction. Look, let's run a little experiment over here. A little experiment. What is SL? 4 miles per hour. And remember, time is the variable of time, and this equation becomes this equation. And this other equation would become this other equation, 24 miles per hour times the time. And remember, what is t for us? T means the time that has passed since Luis started walking. Okay, so now let's suppose the following. Let's suppose the following. Let's suppose that already we have one, let's say that we have 0.5 hours, okay, that already Luis has traveled for 0.5 hours. Okay, so now let's see how much distance he has been traveling. So let's write 4 miles per hour and then 0.5 hours, assuming that that's the time he has been walking. And so if we do that, we get that the distance covered by Luis is going to be 4 times 0.5. It's 2 miles. Okay, after half hour, after 0.5 hours, Luis will have traveled 2 meters. Perfect. But if I introduce that same time into Christian's equation right here, I'm gonna get a contradiction. Okay, I'm gonna get this: 24 miles per hour times 0.5 hours And I'm gonna get that 24 times 0.5, that's 12 miles. And I'm gonna get a contradiction. I'm gonna get this. Why is this a contradiction, guys? Because after 0.5 hours after Luis has started traveling, where is Kristen? Is Kristen at 12 miles? Let me write mi for miles. Is really Kristen 12 miles from their house at zero point 0.5 hours? That's clearly wrong, right? Why? Because she leaves half an hour after Luis starts running or walking. Okay, so basically at, at zero point 0.5 hours, which is the same as this, it's the same as this. 30 minutes is half hour or zero point 0.5 hours. At that time, Kristen is still at her home, and she's about to travel, but not yet. So this number should actually be zero. At time 0 0.5 hours, this number should be zero. You see what I mean? And that's why we need to make that this little arrangement right here, like so, okay, in order for this equation to work. Because if I do that distinction, then I'm gonna have t minus 0 0.5 hours, okay, like you see. And then now if I substitute 0 0.5 hours in here, I'm gonna get this 0 0.5 hours minus 0 0.5 hours, and therefore I'm gonna get 24 times 0, because this is 0, right? And I'm gonna get 0, which now makes sense, because at 0 0.5 hours after Luis starts traveling, Kristen is still at home at 0 miles, and she's just about to leave home. You see? So there is that difference, guys, between these two times. It's a little hard to understand, but now you know why you have to make this inclusion of this this little statement here. 30 minutes after he leaves. Okay, all of this thing is represented algebraically in this way. And now once I've done that, the rest is actually quite simple. So let's erase this. The rest is actually the same as before, exactly the same process as before. We have this equation, we have this equation, and now basically what I want is for Kristen to get to catch Luis, right? So they're gonna be both. I'm gonna erase this again. They're gonna be both, let's say over here, Luis and Kristen. So basically the distance traveled by each of them, this is the distance traveled by Luis and the distance traveled by Kristen. And what I want is for both distances to be the same, because if they are the same, that means that Kristen has in fact caught Luis. So I want this and this to be the same, and I'm going to express that algebraically. If dl has to be equal to dk, then all of this SL times t has to be equal to all of this sk times t minus 0.5. There you go. Line. We continue here. What is SL? It's 4 miles per hour. 4 times t. Remember, you can if there is no ambiguity, you can actually ignore the units, okay, for simplicity. It's maybe not be precisely the best idea, but you can do it, okay, if there is no source of confusion. And then sk, which is 24 miles per hour, or just 24 mathematically, times t minus 0.5. And there you have it, guys. This is the equation. Now that I've come to this equation, I look at it and I go, okay, this is an equation, a linear equation with one variable, which is t. I solve it and I'm done. Let's solve it very quickly. We have 4t, 24t minus 12. Then we have, I'm gonna add 12 in both sides. And then I'm going to subtract 4t in both sides. I get this, right? And then I divide over 20 in both sides. 12 over 20 equals t. And then that's it, right? 12 over 20, that's going to be 4 over 5. This is the most reduced fraction. So 4 over 5. 4 over 5 what? Hours. Hours. Okay? Which is about how many minutes? 12, 40, 48 minutes. Okay, try to understand why 4/5 of an hour is actually equal to 48 minutes, please. And we are done, guys. It's either way. I mean, you can write it like this, or like this, or you can also write it in decimals. For example, how much is 4 over 5? That's going to be 0.8 hours. So these three statements mean the same, exactly the same thing. So after this much time, Christine has already caught Luis. I'm sorry. And the other question is, how far from their house will Christine catch Luis? Well, all I need to do now is just take Christine's equation, okay, which is this one. This is the equation for Christine, okay? And I have to plug my solution. I have to put my solution 0.8 hours in here, okay? And according to with her speed, and that's gonna give me the distance that at which Christine has caught effectively Luis, and that's it. Okay, let me do it quickly with the calculator. You're gonna get 24 times. Okay, you're gonna get. I'm gonna give you the answer only. You're gonna get that the second question is 7.2 miles. This is the solution for B, and the solution for A was 0.8 hours. There you go. These are your two solutions, okay? And try to, even though I'm telling you that these three answers are the same, because they are the same, in fact, try to answer in the same units that the problem is presented with, okay? If the problem has units of hours for time, try to present either this one or this one, okay? Because they're not telling you about minutes, are they? Well, yeah. Let me see. Wait. They also talk about minutes, so I don't want you to get confused. Okay, look. This question. Look at this question. How long will it take for Christian to catch Luis? And they prompt you for the answer, but they give you the units. They give you hours, so you cannot input this one. Okay, you cannot input 48 minutes, because if you input 48 here, you're gonna be saying 48 hours, which will be incorrect. So it's gonna be 0.8 hours, or this one, right? 4 over 5. But they're telling you type an integer or a decimal. So this is the one you're gonna have to input. Okay, guys. So that's it. Those are the two problems. You can see that they can be a little you have to reason a lot, and you have to be very careful with your reasoning. Uh, and there's no way around it, guys. We have to think. We have to develop a taste for problems like this. And we're gonna keep doing this type of problems during the whole next week. And that's about it. Have a great weekend. See you later, guys.